All right, fantastic. Well, thanks everyone for joining today's session. Thanks, Ron. Thanks, Angelbeat. I'm Bert Below. I'm a senior solutions architect here, part of the worldwide public sector at AWS. And today it's my pleasure to talk to you about a new feature and enhancement for an existing service that we announced at this last year's reInvent, GuardDuty Runtime Monitoring for Amazon ECS, which also includes support for Fargate ECS, which has been a big customer ask. And this is going to continue on the general theme of today's conversation of really trying to get additional insights and additional visibility into those container runtimes, which are becoming so more important for internet-facing workloads and enterprise-facing workloads that we're seeing more and more customers are adopting. So it's to kind of start things off, it's really important to understand why we thought we needed to do this and bring this level of threat detection into ECS. And we'll talk about ECS a little bit in depth later in the presentation for those of you who may not be super familiar with that service. So why did we decide to bring threat detection into our containerized service, ECS, and the serverless containers? It's all because these services face the same kind of threats to their workloads that we see in non-container workloads. And some of the more common ones that we see are things like crypto mining. They're things like denial of service bots. They're the nation state actors, the launchpad for intrusion, the command and control networks. A lot of the traditional kind of security challenges that we as security professionals are seeing with more and more prevalence in our day-to-day lives. And this intrusion, the threat actors are certainly beginning to see the containerized platforms as a major vehicle to continue to intrude deeper and deeper into our network environments. So really at the core, what we're trying to do is we're trying to make sure that regardless of what solution you're using, what compute platform you're using, that you have that same level of visibility and a deep level of visibility, not only at the VM level, not only at the network level, but right down to the process level. What is actually making those calls to those threat actors, those command and control bot networks? And how can we actually arm our threat detectors and our incident responders with the best telemetry and the best information so that they can rapidly address those threats to our environment. So quick refresher for those of you who are not super familiar with ECS. ECS is Amazon's native container management service, and it's deployed across a variety of compute options from managed EC2 instances to serverless compute with Fargate, and also in your own on-premise host environments with ECS Anywhere. It's a very mature service. It's been around for several years and has scaled to billions of new task launches every week. And the one thing to note here is that 2 out of every 3 customers who are new to containers, they choose ECS because it's so much easier to onboard and manage. And the majority of those ECS customers who choose ECS for that ease of management are leveraging the serverless capabilities of our AWS Fargate solution to get even less operational overhead on the backs of their workers. And although we've had hundreds of thousands of customers, our biggest customer is Amazon itself. And the use cases for ECS range from traditional databases like RDS to our new AI ML services like SageMaker, and even GuardDuty, which we're going to be diving into in a moment, runs on ECS. On top of all of the hyperscale consumer services that are part of the Amazon.com portfolio, Prime Video, Fire TV, these all run workloads on ECS. And that drives the ECS team to build high availability, high resiliency, and security, and build to a scale that really is capable of serving Amazon workloads. And then that allows you, our customers, to benefit from those economies of scale. So we launched GuardDuty itself about 6 years ago at reInvent back in 2017. And when we launched the service, one of the key tenets we wanted to have was a very full function, but cloud native threat detection service that could be used by customers of all sizes in all geographies and across all industries. And in fact, we have customers ranging from single developers all the way up to some of the largest enterprises, like I said, including Amazon and AWS ourselves. In fact, over 90% of the top 2,000 customers for AWS are also GuardDuty customers. And we are actively protecting over millions of accounts, over 500 million EC2 instances at any given moment, and millions of individual S3 buckets with their S3 data events. In fact, we now process tens of billions of events per minute across all of our global regions, supporting all of these customers. So we're able to provide this level of protection to you. And again, you benefit from that massive scale that we provide. My apologies, getting a little frog in my throat today. So we've come a long way since we first since we first launched the GuardDuty service in 2017. When we first launched it, we had 3 log sources. So that's VPC flow logs, DNS logs, and CloudTrail. And that gave us really good insight into network connectivity. So with flow logs, DNS query result requests gave us the information about what domains were being queried, and CloudTrail, very importantly from a cloud native standpoint, allowed us to understand how our users were impacting and interacting with other AWS services. And as we did so, we started hearing from more and more customers that we needed to increase the breadth and support of the different sources. So in 2021, we launched S3 data events. And this allowed us to get that same level of insight into how customers are accessing objects and buckets with your customer state. So looking at all of those gets, those lists, those puts, those deletes, and those events. And we started seeing more and more adoption across our customer base with container services. So next, we added EKS audit logs that gives you insight into the control plane for customers using ECS. And then later on, added additional support for Aurora RDS login events. So looking for unusual activity from login to your RDS Aurora databases. We added support for Lambda flow logs in 2022 in order to identify supply chain attacks or account compromises that try to leverage Lambda in order to evade detection. And then most recently, runtime detection for EKS was launched in March of 2023, and now we've extended that into ECS and EC2. So let's talk a little bit about what is actually happening under the hood and how we get all of this very important threat detection information. So when we get all this data, we do quite a bit in order to identify different and complex threat types. So we add threat intelligence. And what threat intelligence means is it's what we all probably know as security professionals in the industry. It's fairly common, simple to get. We have lots of different sources, both internally generated and from our threat intel partners. We partner with some of the most well-known vendors in the industry, and we also generate a lot of our own threat intelligence. We have some of the most complex stateful analysis that allows us to look at events as they go through different attack points throughout the attack chain in order to identify complex attack types or attacks that are multi-stage and require lots of different events over time in order to identify them. And we're also heavy users of ML technology to enhance this threat intelligence. We use machine learning and AI technologies against our CloudTrail analysis for EKS audit logs, for S3 data events. And all of these models are specifically trained on identifying unusual anomalous user behavior. We also use machine learning to help augment our threat intelligence with the vast visibility of DNS data across our global regions, which allows us to maintain a very large reputation graph that marks and understands and can help differentiate from that likely benign or possibly malicious domains that are the sources of the threat actors. So if we look at how this service played out before we had runtime monitoring, and this is going to be a continual theme I think you're hearing across a lot of the presenters today. We really started with that visibility we had from flow logs and DNS query logs and CloudTrail. And even for our container workloads, we could see information at the instance level about what is actually happening from that network interface layer. We can tell you about the instance made. We could tell you information about things like the instance made a DNS request or this instance made a connection. And we saw all of that really important threat intelligence through flow logs. But what was really missing, especially for our container customers, was the container level context. So going beyond what the instance, which instance generated finding, which is very important information for a incident responder to have. There's also all of those tasks, all of those processes, all of those pods in the case of EKS that are running on a particular host. And it's really important to have visibility into which task is the individual one that was implicated so that we can properly respond to it. There's also a number of very container-specific threats, so things like container escape activity and other things that aren't really relevant to general EC2 computing, but are critically important to protecting and securing a containerized environment. And then lastly, we wanted to understand process-level events, which again, looking from the data outside the instance, we really couldn't get that level of access into. So in March of 2023, we launched an integration for a managed add-on for EKS customers that brought all of that additional container-specific detection information and container-specific protections to our container customers. And then following quickly at reInvent in 2023, we announced the new ECS and Fargate capabilities. So what this really allows you to do is have that same level of seamless threat detection across all of your Fargate tasks. So general purpose EC2 compute can now use that same runtime agents to get that level of extra visibility and context, which is really just an example of kind of the flywheel mechanism, which is so critical to the scale and the speed at which AWS operates. So let's put ourselves in the in the picture of thinking about an ECS host that is connecting to an external command and control host, a CNC host. So for an EC2 instance, we can understand that we can give you information about the instance ID, we can give you information about the tags, the ENIs, a lot of other metadata. But again, we don't know exactly what is happening on that box that it was communicating with that command and control server. So with the runtime agent capability, we can tell you the exact process ID, its path, its SHA-256 hash that can be useful for doing things like threat intelligence matches, which container that binary was running on, which container image it actually came from. And this can be very useful for detecting things like supply chain attacks, the task name, the cluster name, and the namespace for all of that application within ECS. So now you go from a single instance that has numerous numbers of tasks on it, where we can actually pinpoint down to the individual process level that exact task that's running on that instance that your threat intelligence folks, your security responders, your security teams can narrow in and zoom in on that exact task and figure out exactly how the threat actor got access to that system, what they're doing, who they're talking to, and respond appropriately. So instead of waiting just for the network connection, and in conjunction with that very important information that you get from the network connectivity, the DNS flow logs, the VPC flow logs, there can also be other findings about that activity within the host that we could have detected even sooner. And this just goes a long way to give you that full holistic view, both the high level view and the low level view, to arm your security responders with the best information so that they can respond as quickly as possible. So in the interest of time, we're going to skip past a few of the examples here, but I would refer you to the documentation for the GuardDuty service to see all of the different types of findings, all of the different types of common attack patterns that can be detected and generate findings within the GuardDuty service. So one of the key tenets that we had when we built out this new enhanced service is we wanted to make the installation and the overall operation of the service as frictionless as possible. So we worked really hard with across the AWS organizations. We've built heavy integrations within the AWS organization service, integrations directly with ECS and the Fargate service, removed all of that heavy lifting so that we manage the overhead so that your teams can just get down to the business of protecting your environment. The second kind of concern that I've heard a couple of folks allude to today is around the resource utilization. If you come from a traditional environment like I do, then the overhead of the overhead of an agent running on your VMs or your EC2 environments or your containerized environments are always a matter of concern, and we want to make sure that we have the right balance of giving you the best threat intelligence with the lowest impact to the workloads that you're actually trying to run. So the way we solved this challenge is we actually moved the GuardDuty agent outside of the ECS runtime, and it's running directly in the AWS data plane so that your ECS instance, your EC2 instance, any of these services, any of the compute infrastructure that is actually being protected by the GuardDuty service is going to have zero overhead from the addition of the GuardDuty service. And that allows us to get to a level of efficiency that you're just not going to get with a traditional approach. So we built our agent from the ground up internally, and it's based on the extended Berkeley packet filter, eBPF, which I know we've talked about in some of the other content today. Very common for a lot of container security tools these days, but we did get a little bit different. And then the agent itself is really just a collector of telemetry. So the telemetry that we're receiving from that agent is streamed into our backend. And this moves a lot of the computationally expensive tasks of rule matching, doing the analysis of those events off of your box and onto our infrastructure. And this allows us to do more complicated and complex analysis on events over time. So we also know that it's not always just a single event that is critically important to understand the chain of attacks, the entire threat landscape for us to have detection. And we might need to see a series of events that take place over a period of time in order to have the confidence that it is an actual attack. So this approach really allows us to reduce the amount of infrastructure that's required to run the agent because all of that heavy lifting is done on our side. And it also means that you don't have to keep the detection library up to date or the rule set up to date, which can be a pretty heavy lift for overburdened security teams because all of those rules really happen on our back end. And that means as our team goes and develops new and additional capabilities, adds additional threat landscape, they're automatically available to all of our customers immediately. And there's no updates or any other typical management tasks that you have to do to think about that. So the way we get these events is they come over a VPC endpoint. And then we apply our threat intelligence. We analyze the fingerprints against our stateful rules. These rules are then where we're really looking at, does this event change the previously known state of a container? Or is this a detection where we need to see multiple events in tandem over a period of time to really have that confidence that this is a real threat, this is really something that we need to take action on? So we start to apply some of our machine learning algorithms to look for anomalies, and then we have a whole set of stateless rules as well that can automatically trigger findings with just a single event. And then lastly, we need to make sure that you know what is covered, which of your instances, which of your container workloads are covered and protected. And so from the administrator viewpoint, they have complete visibility across the entire organization that allows you to understand quickly exactly which instances or which Fargate tasks are covered and in which accounts. And that gives your security teams and your security administrators the ability to control that centrally as well. So let's dive a little bit deeper into how we're doing this on the ECS side of things and see how this actually is all working under the hood. At the centerpiece of this implementation is a lightweight GuardDuty runtime monitoring agent, which we deploy on either managed EC2 or on Fargate. And the way that works is when you launch ECS on EC2, you can use the Systems Manager, AWS Systems Manager, to onboard it into the instance. So that runs as a systemd process in the instance that you can monitor. It allows you to monitor the underlying resources as well as your container and all of those tasks running on that instance. Another way to do it is to install the agent as an RPM package from S3. And this allows you to directly install that agent into the instance and monitors the underlying resources for all of your application containers. The other thing you can do on EC2 is set up a dedicated VPC endpoint to get all of that collected telemetry from the ECS side over to the GuardDuty service, where you can actually calculate and generate security findings. And those security findings can be easily viewed by your security administrators in the GuardDuty console. Let's skip to that next slide. So regardless of the approach you take to actually run that GuardDuty agent in your environment, the other important and critical facet to understand is how these security findings can be integrated with other security services in your environment. You can send them downstream to AWS Security Hub or Amazon Detective, or set up automation powered by services like AWS Event Bridge to send it to a third-party security provider. So, and then looking at Fargate, it's even simpler. So in this case, we're running a GuardDuty runtime monitoring agent on an ECR repo and a private repo. So the thing you would need to ensure that you can, the only real task that you would need to take on is to ensure that your task can allow Fargate to pull that image from a repo. And that's it. No adjustments to test definitions. We'll manage this image for you. We'll patch it. We'll upgrade it. And then the next time you launch this new task, either as a standalone or part of a service, we'll pull the latest image from ECR and run it inside your task. GuardDuty also automatically sets up the VPC endpoint. You don't even have to do that. And then the telemetry data can immediately begin flowing into the GuardDuty service to be able to generate the findings that you're going to need to see to empower your security administrators. So here we see kind of the desired state for a lot of our customers, how we can see that very quickly with minimal operational overhead, we can get quick findings, deep level understanding of the threats that are actually impacting your containerized environment, whether you're running it on ECS, EC2, or ECS with Fargate, and how we can actually build out those critical integrations to communicate with your entire security ecosystem, your AWS Security Hub environment, do analysis of the entire threat chain with services like AWS Detective, and build in those very critical automation tasks using Amazon Event Bridge to partner with your existing third-party security services, such as we've seen a lot of immediate feedback and immediate positive feedback from a number of our third-party and customer partners. Here we have a direct quote from Class Method. We've been eagerly awaiting ECS runtime monitoring, and specifically the Fargate coverage, ever since GuardDuty ECS runtime monitoring was announced earlier in 2024. Class Method, or sorry, that should have been 2023. Class Method no longer has to worry about managing and updating security agents to deliver the enhanced security threat detection coverage to all of our customers. And then continuing on the topic of leveraging these services with our third-party security partners, Wiz told us that runtime visibility is becoming an increasingly important component for cloud security. And that's why we're really excited to continue our partnership with the Amazon GuardDuty team to offer joint customers new threat detection, coverage of ECS workloads running on Fargate. The new GuardDuty ECS runtime findings can now be consumed directly from the Wiz security graph, which provides full context around the ECS workload to really help your customers focus on those most critical tasks. And lastly, Flywire investment and runtime security is a game changer. Not only can we be more confident that our systems and data are safe, but having this level of security visibility into our AWS workloads enhances our reputation for reliability and trustworthiness in the fast-paced world of financial technology. With GuardDuty ECS runtime monitoring, we stay one step ahead, empowering us to stay ahead of potential security risks and helping ensure that the peace of mind that our customers deserve. So if you take nothing else away from the last half an hour as a summary, I want you to understand that the key takeaway from all of this is GuardDuty on ECS and Fargate, as well as the public preview of GuardDuty on EC2, really now gives you the full picture, that full visibility into not only what is happening across at that 500-foot view across your entire AWS environment, but down to the task level. And we're incredibly happy and incredibly excited to see how this helps protect our customers' environment. And we, as always, we welcome feedback both on this presentation, but also on the service as well. So if you have any questions, if you have any commentary, please feel free to reach out to me. My email address is right here. Happy as always to be part of Angelbeat. I think we've got a couple of minutes. If happy to answer any questions we have immediately. Otherwise, I'll turn the time over to Ron.